Hello everyone. Today we will be discussing the quick solutions of All India Akash Test Series JEE Advanced Test 4A Paper 1 Mathematics, which was held on 3rd April 2019. So let us start with the question number 41, which says that the number of different types of necklaces that can be made using 13 beads, out of which 11 are identical red beads and 2 are identical blue beads. So we have 11 red beads and 2 blue beads. Now the different type of necklaces is equivalent to finding the number of beads between 2 blue beads. Let us say between 2 blue beads, either we can have 0 red bead, or we can have 1, or we can have 2, or we can have 3, or we can have 4, or we can have 5. Now if I have this B1 and B2 bead, then if I have 6 beads between it, then on the other side it will have 5. So the case will be same as this one, and so on, right? So these are the only cases, that is there are only 6 different types of necklaces to satisfy this condition. So correct answer will be option number A. Next is question number 42, which says that let a function f going from R to R be defined as real part of 1 upon x plus iota fx is equal to 1 and fx is less than equal to 0, where iota square is minus 1, then which of the following sets is not contained in the domain of fx? That is, in this question we just have to find the domain of fx. Now let us assume fx equal to y, right? So real part of 1 upon x plus iota y is given to be equal to 1. So multiplying by its conjugate, we will get x minus iota y upon a plus b into a minus b, that is x square plus y square. This is equal to 1. Now its real part is x upon x square plus y square. This is given to be equal to 1. So we will have x equal to x square plus y square, that is the value of y square is equal to x minus x square. Now from here we will get two functions, that is y equal to plus minus under root of x minus x square, but in the question it have been given that fx, that is y, is less than equal to 0. So the only function is y equal to minus of under root x minus x square. Now we have to find the domain of function fx. Now to find domain, we will find the values of x for which this function is defined. Now this is defined when value inside the root is greater than equal to 0. That is x minus x square is greater than equal to 0, which means that x will belong from 0 to 1, right? Now if we see here in the question, if we put x equal to 0, then the value of y will also be 0. Now if you put here the value of x and y both as 0, then denominator will become 0, but that should not be the case, right? So its domain will be open 0 to 1, right? Now this is the domain of the function. So let us find out which is not contained in the domain. Let's see option number 1 first. These all are contained in the domain, so this is okay. And option number B says that 1 upon root x is greater than equal to 1. As root x is a positive quantity, so it can be multiplied on the other side, that is root x should be less than equal to 1. So from here we get that x belongs from 0 to 1, but 0 in the denominator, that is 1 by root x, will not be defined if I put x equal to 0. So its domain is 0 to 1, right? Which is also contained in this. So this is not our answer. Now option number C says that limit n tending to infinity, it is of the form 1 raised to the power infinity. So how will we find it? E raised to the power, we will write limit n tending to infinity, taking n square downwards and subtracting 1 from 3 plus n square upon 5 plus n square. We will get in the denominator 5 plus n square, and in the numerator we will get 3 plus n square minus 5 minus n square. That will give me minus 2. So this will be equal to e raised to the power dividing the numerator and denominator by n square and then putting the limit of n, that is tending to infinity. We will get e raised to the power minus 2. This is equal to x. Now x equal to 1 upon e square. It also lies between 0 to 1. So this is also contained in the domain. Now option number D says that real part of x plus iota y. Now real part of x plus iota y is x. So it says that x is less than equal to 1, but domain is not containing it. So correct answer will be option number D. Next is question number 43, which says that let f going from R to R be a continuous non-zero function satisfying f of x plus 2y is equal to 2 times fx into fy for every x comma y belonging to R. Then the value of limit x tending to infinity fx upon f of 2 raised to the power minus x is. Now the given function is f of x plus 2y is equal to 2 times fx into fy. Now here if I replace y by minus x, so let us see what we get here. F of x minus 2x, that is minus x, is equal to 2 times fx into f of minus x. So taking f of minus x common, from here we get that either f minus x is equal to 0 or fx is equal to 1 by 2. Now it have been given that the function is non-zero, so this case is rejected. So from here we get that fx is equal to half, which means that it is a constant function, right? So the value of limit x tending to infinity fx is equal to half upon f of 2 raised to the power minus x, that is also equal to half. So the value will be equal to 1. So the correct answer is option number C. Next is question number 44, which says that in a triangle ABC, angle A is 36 degrees. Let I1, I2, I3 are the x centers of triangle ABC opposite to vertices A, B and C respectively. Then the ratio of area of circumcircle of triangle I1, I2, I3 upon area of circumcircle of triangle BI1C is equal to. See, the figure is something like this, where these are the vertices A, B and C and these are the x centers, that is I1, I2 and I3. We have to find the area of circumcircle of triangle I1, I2, I3 upon area of circumcircle of triangle BI1C. Right? Now here let us assume circumradius of triangle ABC equal to R. Now here triangle ABC is pedal triangle of triangle I1, I2, I3, right? So we can say that circumradius of triangle I1, I2, I3 will be equal to 2 times R. This is very much clear, right? Now also let us assume here the circumradius of triangle BI1C, which we have to find, is, let us say, R1, right? Now if I join this line here, then we know that this angle will be B by 2 and this angle will be C by 2. So angle BI1C is equal to B plus C upon 2. Now this can also be written as B plus C can be written as pi minus A. So it will be equal to pi by 2 minus A by 2, right? Now in triangle BI1C, let us apply sine rule. So I can write sine of angle BI1C, that is sine of pi by 2 minus A by 2 will be equal to side BC, that is, let us say, A upon 2 into its circumradius, that we have assumed as R1, right? So it will be equal to A upon 2 into R1. Now sine of pi by 2 minus A by 2 can be written as cos A by 2. Now this is equal to, now again we can apply sine rule in triangle ABC. So we will get A upon sine A is equal to 2R. So I am putting the value of A from here, right? So A can be written as 2R into sine A. Now further it can be written as cos A by 2 is equal to, cancelling 2 here, R upon R1, and sine A can be written as 2 into sine A by 2 into cos A by 2, right? Now if I cancel cos a by 2 on both sides, so we will get the value of r1 equal to 2r into sine a by 2. Now let us find the value which we had to find. Now area of circumcircle of triangle I1, I2, I3, area will be equal to pi into 2r square upon area of circumcircle of triangle BI1C, that is pi into r1 square. R1 is 2r into sine a by 2 whole square, that is 4r square into sine square a by 2. Now cancelling these, it will be equal to 1 upon sine square 18 degrees. Now we know the value of sine 18 degrees, that is equal to root 5 minus 1 upon 4. So the value of sine square 18 degrees will be equal to, in the denominator we will get 16 and in the numerator we will get 5 plus 1, that is 6 minus 2 times root 5. So this will be equal to 16 upon 6 minus 2 root 5. Now if we multiply on the numerator and denominator by 6 plus 2 root 5, right? So we will get it equal to 16 into 6 plus 2 root 5 upon a square minus b square, that is 36 minus 20, that is 16. So 16 will get cancelled. So we get the ratio equal to 6 plus 2 root 5. That is from the given options. Option number C is the correct answer. I hope the question is clear to you. Now next let's move on to question number 45, which says that a chord of the parabola y square equal to 12x touches the parabola y square equal to 8x. The tangents at the extremities of the chord meet on a. Right. Here let us make its diagram first. Let us say this is y square equal to 12x and we have a chord here, right? And this is the second parabola which is touching this chord, right? Now let the endpoints of chord be P and Q. Drawing the tangents at the endpoints P and Q, let us say they are meeting at R and let the point be H comma K. So for parabola y square equal to 12x, if from point R I draw tangents, then the equation of the chord of contact will be t equal to 0, right? That is k into y minus 6 into x plus h is equal to 0. This is the equation of the chord and it is touching the parabola y square equal to 8x. So let us substitute there y square equal to 8 into, let's put x equal to ky upon 6 minus h. Now as it is touching it, so its discriminant will be equal to 0. Now given equation is y square minus 8k upon 6 into y plus 8h equal to 0. So its discriminant will be equal to 0. That is, we will get 4 by 3k whole square minus 32h is equal to 0. That is k square upon 9 minus 2h equal to 0, that is k square is equal to 18h. Now putting x and y instead of h and k, we get the locus as y square equal to 18x, that is it is a parabola. So the correct answer is option number B.